we have Elisabeth Reed. Good morning. How are you?
Hey, good morning. I'm great. I'm so excited to just follow all of those great ideas that Stacy and Sandra presented. And Stacy and I are going to do this together. So this is going to be a great math session leading right from where they led us.
Awesome. Well, let me know if you need anything, and I'll be back here watching the chat for you.
Great. Thank you. All right. We'll give Stacy a second to reset herself. She's going to be the driver of the slides for this one.
Oh,
go ahead, Stacy. What were you going to say?
It should be up and ready to go for you.
I see it, and I see the captions. I was just listening to the AIC meeting, and I'm just so excited about how these things are all coming together to really develop strong Tier 1 instruction now in NTI, and then as we move forward and, hopefully getting to go back soon. So I'm excited to see all of these things coming together. So I'm Elisabeth. I'm your K-12 math coach, and we're excited to share with you about some ideas for authentic assessment and student ownership in math. And Stacy is going to stay with us and talk about some high school examples and get us rolling here this morning. So let's see, Stacy, make sure I can see where you are on your slide so that we're in time. I think you can move forward one. How do we nurture student ownership during NTI? Yep, I see it. Okay, sorry. I have so many windows open. I'm trying to make sure I'm on the right page. So our guiding
I know that feeling.
Yeah, our guiding question for today is how do we nurture student ownership during NTI? And specifically looking at math today. So Stacey's going to share a little bit about our Stool of Mathematical Rigor and our connections to equity.
And so I want to take a moment to revisit this slide. We've seen it throughout all 3 math presentations that we've done this month. And why is student ownership important? And for us, it's important because it connects the student building their identity as a mathematician. Our goals as math teachers is that every one of our students see themselves as a mathematician in the world around them. And this occurs during the conceptual understanding and the procedural fluency component, which falls into the culturally responsive education, indicated by the blue and the purple arrows. And so within this, we have to build the foundation. So we begin bringing multicultural education and social justice education to students in a strong mathematical identity, and that they can apply the best strategy based on the context of the problem and what they've engaged in and how they've built their learning. So we want to continue to build that within our students and through our opportunities and the structures that we provide. So I'm going to turn it back over to Elisabeth to dive into some of our structures.
So let's think about what this looks like in mathematics, because it's a little different from some of the other content areas. So what does student ownership look like and sound like? We really want to focus on the idea of students thinking, sense-making, and developing their reasoning. Students must have the opportunity to be actively engaged in rich tasks, grade-level appropriate tasks, that open the doors to creative and diverse solution paths instead of only passively receiving procedures and steps. If we look at this continuum, we know that kind of just watching someone else do the math, they might develop some understanding and show some compliance, but we want to move kids from that teacher-centered into the learner-driven culture of our classrooms, where kids are really invested in their learning. According to Jo Boaler in her book, Mathematical Mindsets, she says that when students are asked to think intuitively, many good things happen. First, they stop thinking narrowly about methods, and they consider mathematics more broadly. Second, they realize that they have to use their own minds, and they realize their task is to think about the appropriateness of different methods. And third, their brains are becoming primed to learn from each other and learn from classroom discussions. So let's revisit that strategic planning guide that Stacy shared with us a few minutes ago, and let's dive a little deeper into one of those sections. So as you're thinking about planning, focus on where student thinking might progress through the unit of instruction and where you're going to place those checkpoints to monitor their progress towards mastery. What questions might you need to develop as a teacher to make the connections within the unit to previous units? so that you're activating student schema and building upon the strengths and the assets that they bring to the classroom. As a teacher, we have to intentionally build our units of instruction in a way that fosters students' movement through that ownership continuum, from just understanding and compliance into autonomy and true investment in their learning. These questions on the screen are going to help us frame our units so that student thinking and progression through the continuum are really the focal point of our work. So let's move forward a slide and take a look at a second grade example. In second grade, the major focus of the grade level is on developing place value understanding and using a variety of strategies to add and subtract numbers within 100. Students enter second grade having used their fingers and physical counters or Unifix cubes to make sense of adding and subtracting within 20, using strategies like making a 10 or modeling on 10 frames with concrete objects or drawing representations. And those you can see in the two images on the left, the fingers and counters on 10 frames in the top left, and then the Unifix cubes in the bottom left. In second grade, we build upon their understanding of 10-ness to develop the idea that a 10 is a unit of place value. Students engage with a variety of tools as they develop their understanding of the structure of our number system, and they use it to solve problems, which is standard of math practice number 7. We do not teach the standard algorithm or use tricks like borrowing that are not mathematically sound. Instead, we allow students to use what they know about tens and ones to deepen their understanding and apply it to a more complex and sophisticated set of problems within a larger range of numbers. Let's take a look at that larger image on the right. This is a which one doesn't belong number routine from second grade from the illustrative math curriculum. In this which one doesn't belong example, students will begin to connect the ideas of those concrete cubes, like you see in image A, to base 10 blocks in D, to visual models like the part-whole diagram in B, to a graph, which you see in C. When students have time to consider how each of these is alike and different, the teacher can then ask a question like, how does each representation show us the difference between cloudy and sunny days? The teacher is then eliciting evidence of student thinking that is used for formative assessment to propel learning forward in the lesson, just in time, in the moment. Additionally, students are primed to consider tools or representations that are new or less familiar to them as they continue with the work of the lesson and this unit on adding and subtracting. My middle school friends out there will really appreciate image B because it starts to make us think about our double number lines and our tape diagrams that we use in 6th, 7th, and 8th grade. Using these representations is modeling in mathematics in the primary grades, which is our standard of math practice number 4. Additionally, this concrete representational abstract sequence, moving students intentionally from physical models to more abstract numerical expressions and equations, is how we give every student an entry point into the grade level mathematics. Last week, Amy Crawford shared a clip of a kindergarten class and some students exploring a dot talk. When students are able to share how many they see and how they see them, we are valuing even our youngest students as producers of mathematical ideas, building their identity as mathematicians. By comparing their strategies for finding the total, the teacher can assess if students are counting all the dots, counting on from a known quantity, which is a very big transition that kids make in kindergarten and first grade. Are they subitizing? So can they just look at the dots and see how many there are in a specific arrangement? Or maybe they're even using doubles facts. For example, in the red image, kind of in the center of your screen, that student might have said that they see 2 lines of 3, doubled 3 to get 6, and then counted on 2 more, 6, 7, 8. In the green image, the student may have subitized the group of 5 that looks like the pips on a dice, and then counted on 3 more to get 8. Once the teacher knows what strategies a student is currently using, they can then plan instruction to move the student along in the progression of fluency strategies, making mastery of that grade level standard the goal by the end of the year. Additionally, the students are going to hear their peers' strategies. They're going to also begin to internalize those strategies. And this is where the idea of math as a shared exploration comes into play, giving more students a chance to contribute to collective problem solving and a communal understanding of mathematical concepts. When everyone's ideas have strength in them and the teacher points out their value because of the connections between them, students will begin to make these connections on their own and build on each other's thinking, both reviewing their understanding and deepening it at the same time. This is moving students along that continuum from compliant understanding to active investment in their learning. And I think about Zaretta Hammond's moving from dependent learners to independent thinkers. It is culturally responsive and evident right here.
So as we move into a secondary example, this is a demonstration and a short video of two students working together in a breakout room, and they're fostering some ownership of their own learning here. They're moving a little bit from they're trying to grapple with the understanding and verbalize their thinking with how they might represent a situation using that describes candies, but using an actual mathematical expression. So let's take a few moments and listen to the conversation that these students have.
Oh no, I don't think we are hearing that. Let me see if I can get...
Oh no!
That's okay. That's okay. I can get that pulled up really quickly for us. Let's see, what slide is that?
It was slide 8.
Slide 8. Okay. All right, let me jump in. Give me 2 seconds and we will get this. This is the beauty of live sessions. Let's see. There we go. Put this in. And I'm 2 clicks away, so just a second. There we go.
You're okay.
Thank you for doing that, because I think the student voices in this are what's so powerful.
Absolutely, yes, it is. And I've seen, let's see. Okay. Got to share my screen first. That would make sense. And this one, share screen. There we go. Okay, it says no. Hold on just a second. I can definitely do this.
Do I need to stop sharing?
No. It's a setting on my computer that was being mean to me, so it's okay. We got this. Yeah. It is not you. Okay. Getting it. There we go. Okay. You cannot see it, ladies, but everybody on YouTube can. So just so you know.
Oh, okay.
Here we go.
The shoes are $3, or not $3, 3 cents more than the lollipops. So we might have to do some math here.
The lollipops, since she bought 4, they'd be 40 cents, and the chews would be 7 cents because there's 3 less.
Yeah. Or it says 3 more than the lollipops.
Well, yeah.
So Sarah bought 2 strawberry chews.
Oh no, it's not showing the video.
So if the
Oh, it is. Yeah, they just can't see it.
Chews,
You can't see it, I'm sorry. But the online can.
So it'd be 6 cents. It would be 6 cents above the lollipops because she bought 2. So I think we would do this one's a little tough. So she bought 6, or that'd be the cost of how much she bought, and then 4 lollipops. I keep saying would we subtract 6 from 54?
There we go. That was good. I love his, oh wait a second. This is a tough one.
Yes. And so that productive struggle is what we want to talk about when we talk about facilitating some ownership in mathematics. So as we switch over, can we see my slides again?
Yes, we can.
Okay, perfect. So facilitating student ownership, and during that previous clip, we saw the students in their little small breakout room discussing their ideas. But during the time as a teacher, we're monitoring and identifying those key points of discussion to share with a whole group in the synthesis. So specifically, the types of questions that were posed to students during the session, which as you can see in the bottom right-hand corner and outlined in red, that was the task that students needed to kind of think about and be able to discuss. And with the types of questions we now bring up as teachers in the synthesis section, we're either solidifying the student ownership or we're going to break down their competence. We must be intentional about fostering the ownership so that students build up their confidence by highlighting the connections that we heard in their thinking to the actual new learning that's taken place. So the questions specifically that students were given to explore just were a starting point for conversation. As you saw, it took them in other places. They really identified that, man, this one was a little bit more difficult. And yes, it was the most challenging on the page. But with these students, it allowed them to start kind of diving into what do we need to do? How do the numbers relate to each other? How did they get represented? And in the synthesis of the lesson, revisiting the importance of identifying that variable, which they talked about identifying as well, really stretches their reasoning within the capacity of the context. And so the video represents students moving from an understanding and starting to invest in it a little bit further because they stuck with it. They tried it. They just didn't skip and go to the next one. They were invested in it because they internalized the thinking process that developed their new learning. So how might we ensure this process continues along this learning continuum? And we must build in those authentic opportunities like you saw that discuss and demonstrate and allow students to show what learning and thinking they've got. So Elisabeth, how do we create authentic opportunities that demonstrate this learning?
Yes, let's go there. This is great. And I have to say, Susie, that's one of my most favorite fouls to do, the formative assessment lessons to do with kids in middle school classroom, in 7th and 8th grade, 8th grade specifically, and looking at finding that one little nugget of great thinking that the kids are latching onto, and then asking that great question that propels them to the next level. That's one of my favorite ones for seeing what kids know and can do.
Absolutely.
Yeah, let's take a look then again at those 3 pillars of flexible assessment that Stacey was sharing a little bit ago in the opening session. So you guys, if there's one thing we've learned this year, we know flexibility is the key to 2020, right? So what does that mean for assessment? We know we've got to move beyond paper and pencil tests and quizzes, and a lot of us already have. So we're really looking for those authentic, flexible assessments that can occur over time. It should not be an isolated one-time deal. Assessment should be ongoing and measuring that progress towards a goal or mastery of a standard. The second one there, assessment should be in the form of feedback to allow students to monitor that progress towards their goals and mastery. So just like we saw in that FAL, what's that one thing that you could ask the students or point out to kind of help them move forward? What's that great feedback? And we have some elementary teachers that are going to give us some insight into that this afternoon on the channel here. And then finally, there needs to be a balance of assessment for learning, not simply of learning. So that really is to say that it's integrated into the moves that the teacher is making throughout the lesson. Multiple points of assessment that are quick and targeted will, again, propel that learning forward in the lesson. So I recently got to watch a webinar put on by the Distance Learning Playbook authors, and it's linked in the slide deck if you'd like to go back and watch it. It was called Measuring Student Learning in Any Setting. And they focused on the guiding question of how do we even know what our students know, especially in virtual learning right now, working through a screen, how do we really know what our kids know and can do? And they focused on 5 types of assessment for virtual learning. And we're going to dive into 3 of these specifically. So So let's start with the universal response. Universal response is targeted in the lesson. It's going to be a way for students to respond at the same time. So the real key idea here is that every kid is accountable for answering the prompt or giving their feedback simultaneously. And the research is showing that we should be using these types of micro-assessments every 10 minutes at least in our synchronous session. So not only is that going to give us increased engagement and participation and accountability, but it's also going to give us those quick checks to make sure our lesson is on target and we're meeting our goals for that day. A lot of people are already using this in the form of the waterfall chat, right? We've seen classes where the teacher will give a prompt, ask everyone to type into the chat, but not hit enter until the teacher says waterfall. So that's a great way for every kid to be accountable for responding and having that opportunity to respond, but it reduces the follow the leader syndrome. So instead of the first student replying and then everyone kind of saying, oh yeah, I agree with that, and just kind of going along, kids really have to think about their own response. And then if their response is different, maybe it's incorrect or maybe it's just different from what they see their peers populating the chat with, it's really going to prompt those kids to consider what they know or think or what maybe they realize they don't know. So there's a lot more intentional thought that's happening on the part of the student, again, moving them more towards that investment and ownership of their learning. And of course, the teacher can give them feedback to everyone, not just to one student and play that ping pong game back and forth, but really think about the holistic and giving that formative assessment to every student at the same time. Stacey's going to talk to us next about an example for reciprocal teaching.
So teach back or reciprocal teaching is one that's been around for a while. And most of the time, teachers use it as a way to assist, to get some assistance in the classroom, but we want to change that idea. We don't want to use students as additional teachers, but we want to make this an assessment for learning so that they're working together more in a collaborative setting and learning from and with each other, and an opportunity to have some dialogue where students really start to see kind of the connection. A way that you can work with it, as you see on the screen, is this idea of retelling or using screencasts or Flipgrid. But also you can utilize breakout rooms or the synthesis portion of your lesson to really start to highlight some of the information. So here in just a moment, we're going to watch a clip of some of the same group of gentlemen that you saw earlier, but on a different lesson. And so within this lesson, this clip highlights how the teacher might facilitate identifying multiple approaches and making the connection to the new learning of solving equations in this case. Prior to this clip, students were engaged in this what if warm up to where they were bringing that concrete representation of a hanger diagram into the idea and kind of how do they find missing pieces for a variable. So during the explore part of the class, students engaged in small groups to where they took more the abstract representation of the equation and started to identify what might be some verbal descriptions of moves that they could make to keep the equation balanced, this idea of equality. And students had to determine which of the moves were appropriate. Now, within their work, they may or may not have in their own individual ideas taken that exact move, so they had to explore it a little bit further to see which move was still okay, which one was a balanced move. So in the clip, the clip shows the teacher acting as the scribe for two different students who share how they determined if a given equation was equivalent to one already solved on the screen. So here, listen closely for indicators of student ownership as well as some assessment for learning.
Okay, I'm going to go ahead and play that for us, okay?
Perfect.
What about equation one? Would somebody give you guys a minute, or if somebody wants to talk us through, with equation A here, would it be the same solution as this equation you just worked with?
Yes.
I think so. He's looked ahead. No. Correct. Yes, Malachi. That was the question. Does equation A have the same answer of x equals 1?
Yes, it does. I just figured it out.
How did you figure that out so quick?
Yeah, because
Hold on. I got Malachi.
All I did was put in 1 into the equation. It was 2 times 1 minus 6. I got -4.
Okay, hold. Shoot, no.
Nice.
You are speaking a heck of a lot faster than I could write. 2 times 1, -6, and that gave you what?
-4.
Okay.
And then that's when I just did the same thing, 4 minus 8. And then 4 minus 8 times 1. And then I just put, and then that got me -4.
Okay, thank you so much. So all he did was just verify his solution by substituting in. Is that okay to do?
yeah.
Yeah, absolutely. Is there another way, though, that I could have checked to see if x equals 1?
Yes.
What could I have done?
Well, first, I added 6 to the 4 because I do the inverse operation.
Awesome. Thank you for that vocabulary usage.
Oh, yeah. You already know.
I like it. Oop, that should be a 6. Caleb, yes, question.
Does inverse just mean backwards, pretty much?
Yeah, opposite.
Right, okay, solid that.
Yeah, that's a big vocabulary word as you guys move into high school, that you'll hear inverse instead of the word opposite. So, got 2x equals, and then continue, Kane. Where were you going?
So then after that, I would have 10. I would have 2x equals 10 minus 8x.
Okay.
After that, what you gotta do, you gotta move the negative 8x over to the 2x.
Okay.
You gotta do the inverse, so then you add the 8x over to the 2x.
Beautiful. And I'm going sideways now.
And then once you divide the 10x by 10, you get 1 equals x. I mean x equals 1.
Oh. That's a 10.
Where'd you get 12?
I didn't mean to. I meant to do 10. Thank you.
Then you divide the 10x by 10, and you get x equals 1.
Nice, man.
Thank you for catching my 12, too. So there's 2 methods, 2 ways you can do it. You can solve it out just like we would normally do by keeping things balanced with those inverse operations. But I could also, if I know the value, you can do exactly what Malachi did and substitute it in. So you have a couple of different ways in which you could check to see if it matches or not. So I want you guys to try this next one.
Awesome. That was exciting that they are like, wait a second, inverse. Does that mean opposite? I loved
Absolutely.
it.
So there were some key indicators there that the kid was owning his own learning. He was like, wait a minute, I don't understand what this vocabulary word means and what he's meaning in relation to this problem. But hey, I'm going to ask. But before the teacher could even respond, the kids supported him. They supported him as like, no, dude, it's just the opposite or the other, backwards, and they really tried to work together in that collaborative learning. So this is an example of where those kids moved from that understanding phase to now they're invested in the problem and they're invested for and with each other. And so this sample, hopefully you heard some other key phrases or key things from not only the teacher but the student that then could lead us into this idea of peer and self-assessment that Elisabeth is going to take us through. So think about what are those key things within that clip and the other clips you've seen that not only are moving students along the continuum, but could be assessments for the learning.
Yeah, I love that. Stacey, we have to also stop and point out some of the amazing teacher moves that you did in that clip that made that possible for the students to have that conversation. When you had the hanger diagrams and as you were annotating the screen, those were making, that made all of their thinking visible so that the students could visualize it and hear what their peers were saying and help make sense of it. You had your questions pre-planned. I saw Andrea shout out in the chat, like the how questions. I mean, you had so many intentional moves through that lesson that facilitated that conversation for the kids so that they could have the opportunity to take ownership of their learning. And that goes back to those planning questions that we mentioned a little bit ago. So I don't want that to get lost. That was really, really important and very awesome. So, okay, let's dive into this because I know we're running short on time. So when students have the opportunity to engage in some peer assessment and in some self-assessment, we realize again that importance of our math community. So thinking all the way back to the beginning of the month, do our students feel safe to take risks and talk to each other and be vulnerable to share their thinking and their questions and their ideas, like we heard that group of boys? We've also seen some great examples, not just that one of the breakout rooms, but I'm thinking about the clip that Andrea showed last week from Mr. Stahl's classroom at Chansey, where he was popping in and out of breakout rooms as pairs of students were discussing one of those which one doesn't belong prompts. When the students returned to the main room, Mr. Stahl not only had evidence of their engagement and participation, but he also had evidence of math language and that vocabulary, like Elaine mentioned here too, and their depth of understanding. So how might we be able to use these conversations to formatively assess our students and also for students to assess themselves? Consider these suggestions for peer assessment in breakout rooms. When kids come back from their breakout rooms, if they have their cameras on, have them do a quick rating from 1 to 5 using their fingers to rate their breakout room conversation. What might it reveal if students in the same group have very different scores or very different experiences of that breakout room? There might be some implications for community or for content. How might students be able to rate their conversation specifically tied and related to the learning goals for that day? Or how might they be able to then set goals for future collaboration based on the norms that we have in our frameworks from Joe Bowler? And we have an image and a link to those here. These norms are really important messages to share with our students as we seek to move toward that learner-driven culture, where students are building their identity as mathematicians and taking ownership of their learning and growth. So think about for that self-assessment piece, how might students be able to reflect on maybe a chosen norm or specific area for growth? And how can we build that into our weekly and unit plans?
And so as we take this moment to kind of wrap up, we've highlighted a lot of the different components and things that have been shared over the past 2 weeks. So we want to highlight, if you've missed those, please feel free to click and go back and watch the videos on the previous 2 sessions that highlight some of these moves that we talked about today. We also want to draw your attention back at 12:30 as we have some great teachers talk about in the moment student-centered feedback that are used for assessment, as well as just really fostering that student ownership. And then we also want to draw your attention, lastly, to some of these great resources so that you can dive in your own time. So thank you for your time and attention. Elisabeth, I think it's been great. Elaine, we'll toss it back over to you.
Thank you, ladies, so much. I love learning from you guys. Thanks again for coming.